All right, Honors Algebra 2, we're back. We have another lesson where you need to go get a piece of paper. So go do that right now. I'm waiting. Okay, now today we're going to talk about how to simplify variables with exponents under a square root and how to work with square roots with both imaginary numbers and real numbers. So first thing we want to talk about, how do you simplify variables? So simplifying. We're going to simplify exponents. Alright, so let's look at what we have first. First thing I want to talk about is square root of 4. Basically, when we were breaking things down, we were finding pairs of numbers that you have. And then with pairs, one of them comes out. Because this is basically the square root of 2 times 2. There are 2 of them in here, so the square root of 2 times 2 is just 2. This works for variables as well. For example, if I have the square root of a to the 8th, that's the same thing as saying the square root of a times a times a times a. Okay, 8 a's. Well, how many pairs of a's do I have? You should hopefully see that there are 4 perfect pairs of a's. So that means this simplifies to be a to the 4th power, because 4 of them come out. Alright, and what do you notice about the exponent? You're basically dividing the exponent by 2. Okay? Now, some of you guys might be wondering, well, what happens if it's an odd number? Because then you don't have perfect pairs. Well, let's look real quick at that. If I have the square root of, I don't know, a to the 13th. You can rewrite that as, well, how many pairs are there going to be? Or you can think of it as this. Get it down to an even number, a to the 12th, times square root of a to the 1. This is the same thing. I broke out 1a to make this one even. And now that this is an even number, you can divide the 12 by 2 and say that that just becomes a to the 6th, and we still have a root a left. So that's how you simplify exponents with variables when you're taking the square root of them. So now let's look at some problems that we can do together. Number 1. We have this big thing. Square root of -7 a to the 4th b to the 5th c squared all over 14a to the 5th. Now, I know we're going to talk more about exponent properties in the next chapter, but hopefully you guys realize that when you divide, you can cancel out and simplify. First thing you should always do before breaking all these down is to simplify the fraction. So simplify this fraction first. So I'll write that, simplify fraction. Okay, so let's see what happens inside there. We still have this big square root. -7 over 14 is -1 over 2. There are no b's on the bottom or c's, so those stay the same. And then notice how there's 4 a's on top of 5 on the bottom. So if we had a times a times a times a on the top and 5 of them on the bottom, 4 of them will cancel and you'll be left with 1a on the bottom. So now we can take the square root of everything. Remember, this square root means square root everything on top and on bottom. So the square root of -1, you guys should remember from yesterday, is I. The square root of b to the 5th, you should get b squared. In fact, I like to put the letters first. C squared is c, and we are left over with one more b. Okay? So that's what the top looks like. The bottom looks like just the square root of 2a. So I hope everyone sees how we went from here to here. Again, b to the 5th, there are 2 pairs, so there they are. And then there's one b left underneath the square root symbol. C, there's 1 pair, so 1 comes out, and the -1 becomes an I. Finally, we cannot have square roots on the bottom, so we multiply the top and the bottom by square root of 2a. So my final answer for this problem is b squared ci root 2ab all over 2a. Okay, so that is how you simplify fractions with exponents and square roots. And this is what I want. No exponents, or not, I shouldn't say that. No imaginary numbers, no radicals on the bottom. Alright, so that's number 1. Number 2, we have 2 root 10 over I root 20. Now before you go and just start multiplying things, you can simplify fractions again if they are both the same. These are both radicals. So this becomes 10 over 20 is 1 over 2. 2 root 1 over I root 2. Well, root 1 is just 1, so that doesn't matter. So now we have to simplify. Remember, to simplify radicals on the bottom, you multiply by root 2. And to simplify i's, you can just multiply by another I. Okay? So I'm going to multiply the top and bottom by root 2i. So I get 2i root 2 on the top, and the bottom becomes 2 times I squared. And everyone should remember from yesterday that I squared is the same thing as negative 1. So I get, and then you can also cancel out these 2's. So I get I root 2 over negative 1, which simplifies to negative I root 2. Because these 2's cancel. Alright, that's number 2. Number 3. We have 3 over 6 plus root 2. Now, this is very similar to yesterday when we were dealing with i's on the bottom with pluses or minuses. Same thing applies for radicals. If I have 6 plus a root, the way to get rid of a root on the bottom is to multiply by the conjugate, like we did yesterday. Conjugate works the same in this case as well. 6 minus root 2. 6 minus root 2. So the top becomes 18 minus 3 root 2 all over 36 plus a 6 root 2 minus a 6 root 2. Those cancel, and then minus 2. Because they have negative root 2 times root 2 is positive or negative just 2. So my final, well, not my final answer yet. Let's see what we have first. So we have 34, and sure enough, we can't we can't simplify it in this form. But if we break it apart, so we have a real and a rational and an irrational part, we could say this is 18 over 34 minus 3 root 2 over 34, which turns into 9/17 minus 3 root 2 over 34. Okay, I just broke that apart. But again, the big important detail for that problem is to multiply by the conjugate, and then it's just some math. Okay, 4, this is just a review. 4 actually is a review from yesterday, and it incorporates radicals as well. So we have 5 over 3 plus I root 5. Okay, so I look at the bottom, and I don't want radicals or imaginary. So I need to multiply by the conjugate of both of this, and it's 3 minus I root 5. 3 minus I root 5. So you get 15 minus 5 I root 5 on the top when you multiply that in. When you FOIL this, you get 9. This and this cancel, and the last one is I squared, so it's a minus I squared times 5. Because root 5 times root 5 is that. So what do I get? I get 15 minus 5i root 5 still over, this becomes a negative 1, so negative 5 plus a so negative minus a negative 5 becomes positive 5 on the bottom, so 9 plus 5 is 14. Alright, and then to break it apart, so you have a real and imaginary part, we get 15/14 is our real rational part, and then we have minus 5i root 5 over 14 for our imaginary part with a radical. Alright, now, last two things we're going to talk about. Okay, remember how we were completing the square to find vertex form, and then yesterday we were solving by taking the square root. We could put, or not yesterday, 5.3 we were solving by taking the square root. So now we're going to, it's basically the same thing. Solve by completing the square. It's basically getting it so you can solve by taking the square root, but you have to do one more step. And again, this is the alternative to quadratic formula. So for example, number 5. I have x squared plus 8x equals 24. Well, most of the time, this is a little different from completing the square when we were trying to get into vertex form. In vertex form, we had the y on one side and then everything on the other. Okay? When we're solving, though, it's actually set up pretty nicely for us right now. We have our numbers on this side, and we have the two pieces we want to complete the square with over here. So what happens is I can rewrite this as x squared plus 8x plus blank equals 24 plus blank. Now, before, remember we were adding and subtracting numbers on the same side of the equation. In this situation, since I'm adding to both sides, I'm going to do the same thing to both sides to keep the equations balanced. So pretty much, you always have to keep the equations balanced. So half of 8 is 4, and 4 squared is 16. So if I add a 16 on this side of the equation, I have to add a 16 on this side of the equation, the other side. The other thing you can think of is if you add 16 to this side, you have to subtract 16 on the same side. That's what we were doing before. But we can just move it over and add 16 to this side. So what happens is this becomes a perfect a square of a binomial. And you get, what, 40 over here? Oh, yeah, we get 40. But let's change something first, actually, everyone, before you work ahead. Let's make this a negative. Let's make that a negative. So it shouldn't be 40. I want negative 24 plus 16 because I want a negative 8 here because I want to deal with imaginary numbers too. So now we basically are at this equation, which kind of was vertex form. Vertex form was if we had the 8 over on the other side. But we're trying to solve now. So now this is where we're taking the square root. So I take the square root. I'm not done yet. I just wanted to box that to show you where we're at. If I take the square root of both sides, I get x plus 4 is equal to the square root of negative 8, or plus or minus the square root of negative 8. We're going to have to fix that, though. X is equal to negative 4 plus or minus. Hopefully you guys realize that 8, the square root of 8 is 2 root 2, and then the negative makes an I. So this is my final answer. And again, if you would do quadratic formula with this, you would get the same thing. But this sometimes works better, especially if you can complete the square with nice numbers. Alright, let's look at number 6, and then that's it. So let's just do one more of completing the square. And why don't you guys try this first on by yourselves. Alright, so pause it if you want to see what you think you can do. Otherwise, let's keep going. The next step would be to move the 3 over. So again, when we're solving, you want to isolate these guys over here. And I'm going to pull this out and say this is x squared plus 6x equals, and I move the 3 over, and I get a negative 10 then. So I'm going to add, so the divide by 2 is 3, squared is 9. If I add 9 on this side, I have to add 18 on this side because I'm adding a 9 times a 2. Okay, and again, because it's on the other side of the equation, that's why I'm doing the same thing. So I get 2x plus 3 quantity squared equals 8. Divide your 2. Now we're just solving. So if I divide by 2, I get x plus 3 quantity squared equals 4. Take the square root of both sides, and you get x plus 3 is equal to plus or minus 2. So what that means is there's two equations. We got x plus 3 equals 2 and x plus 3 equals negative 2. So x equals negative 1 or x equals negative 5. Again, an alternative to using the quadratic formula or factoring. Completing the square is a nice way to avoid quadratic formula, and you get the same thing. Okay, we're going to practice a lot of these in class today. Well, whenever we have class next. So if it's the weekend, you have it on Monday. If it was another day, you'll have it tomorrow. So anyway, I will see you guys then.